Okay, after we were rudely interrupted by the 5-minute time limit that we have to do these videos, or recordings I should say, back to what I was saying about the change in H and change in S for the following reaction, the methanol reaction. Using the table that I provided you, we get the equations for the products minus the reactants. Essentially, change in H is the negative 1,453.2 kilojoules, and the change in S is the negative 0.16184 kilojoules. And remember, you have to convert the values for change in S from joules to kilojoules. For number 2, given your answers to question 1 and the fact that this reaction takes place at 25 degrees Celsius or 298 Kelvin, no degrees on Kelvin, calculate change in G using the change in G equation that we've used so much during this tutorial. Change in H minus T times change in S. Plug in your values that you got from the previous question, and basically you get negative 1,404.9 kilojoules. So a certain reaction is non-spontaneous at room temperature and spontaneous at high temperatures. What are the signs of change in H and change in S? Well, change in H would have to be positive. I'm not really sure why. I mean, Swisstack can teach you, but change in S definitely has to be positive because you want to you're multiplying that by the temperature. Therefore, as your temperature increases, you want to keep it a positive number, and you don't want to make you have to subtract by a negative, and that just gets all messy. So basically, the higher your temperature is, the greater that side of the equation is. And that side of the equation, if it's greater, it will make a negative change in G. Now, that's given that change in H is positive, which it has to be. Remember that. And if you have lower temperatures, then basically room temperature, if you have, say, I really messed this one up, but I'm going to keep going with it. So change in S, if you have a room temperature, change in S is positive, change in H is positive, you will have a change in G that is also positive, therefore it's non-spontaneous. And you can do the work if you want. I mean, just plug in any values with room temperature in Kelvin, of course, and you'll find out that you get a negative change in G. Trust me, I'm not lying. And let's just go to number 4, because that's a lot more simple. Calculate the change in G for each of the following reactions. Indicate whether each reaction is spontaneous or not. So we have A, our first reaction. Basically, use the tables. That's my advice. Use the tables. Change in H, you get the values. You have products minus reactants. You get a value of negative 74.2 kilojoules. Same thing with change in S. You want products minus reactants. If there's coefficients, multiply those values by the coefficients, and for the change in S, it is negative 0.2328 kilojoules. And now just use the free energy equation, plug all those values in. We're going at a temperature of 25 degrees Celsius, which is 298 Kelvin, and we get a change in G of negative 241.86 kilojoules. Therefore, since it's negative, it is spontaneous. For B, for the B reaction, it's the same process. You want to find the values on the standard table for each. So for change in H, you have products minus reactants. You get negative 1,076.6 kilojoules. For the change in S, you get negative 0.0562 kilojoules. Now plug it into your free energy equation, and it's almost like this stuff makes sense. It equals negative 1,058.4 kilojoules, which is also spontaneous because it's negative. And now I have 5 seconds left, so I'm going to wait to make a part 4.